So you don't need to provide anything to me for the moment. Trig starts with these two triangles. Actually, trig starts with this. I'm going to ask you to memorize everything I write on this page. And if you do, you're going to be able to do any angle that I give you. Okay? So start there. And then you have a 30-60 right triangle. You've been dealing with this triangle for years. And you have a 45-45 right triangle. You've been dealing with this triangle for years. It's not what you have to memorize is their side lengths. And your book probably follows this with an X because it can be any multiple of this. But like the unit circle, I call these my unit special triangles. Okay? Between these two triangles, you can answer any first quadrant angle. I'll show you. What's the sine of 30?
For which one? The right?
There's only one 30-degree angle on there. What's the sine of
it? I would go with 2.
What's that mean?
1/3.
No. What's SOH mean?
I don't know, man.
Opposite over hypotenuse. What's CAH mean?
Adjacent over hypotenuse and opposite over adjacent.
Okay. So what's the sine of 30 degrees? What's the opposite over the hypotenuse? Read it off that triangle. What's opposite to the 30-degree angle?
1.
What's the hypotenuse?
2.
Okay. Tell me what the sine of 60 degrees is based on the triangle.
√3/2.
Tell me what the sine of 45 degrees is.
1/2.
1 over √2. Okay. And then that should be rationalized to √2. Okay. What is the tangent of 45?
1/1.
What is the tangent of 30?
Tangent of 30 is 1/√3.
That needs to be rationalized also, so I get √3/3. So I think you can see that no matter which trig function I gave you, if the angle was 30, 45, or 60, you'd be able to get it with these two triangles, right?
Mm-hmm.
So memorize those two triangles. I'm going to erase everything else. You've just mastered the first quadrant. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. So if that's a 30-degree angle, you know what the cosine of 30 is, right? What's the cosine of 30?
1/2.
That's the sine of 30. Cosine is adjacent over hypotenuse.
Adjacent over hypotenuse, that would be √3/2.
Yeah. Okay, now, so we're good in the first quadrant. You can do every one of those, no matter whether I gave you secant or cosecant or cotangent. As long as the angle is 30, 45, or 60, you're going to get it from these two triangles, right? Now let's talk about angles that are in the second quadrant. If you apply this, this gives you the equivalent first quadrant angle. In other words, if I said to you, what is the sine of 150, plug it into this expression, that means it's the same numerical as the sine of 30. Well, we know what the sine of 30 is, 1/2. That means the sine of 150 has to also be 1/2. But now we need to figure its plus or minus sign. All students take calculus. What is the sine of a second quadrant angle? What is the plus or minus sign of the 150-degree angle?
I don't know.
What's the S mean? Now let me write that differently. I don't usually write it like that. I usually write it a little further away. Write it, all students take calculus. The A means all 6 trig functions are positive in the first quadrant. The S means only the sine is positive in the second quadrant. The T means only tangent, and the C means only cosine. Now, when I say only sine, well, we know it's reciprocal, has to carry the same plus or minus sign, so it's really sine and cosecant. This one's tangent and cotangent, and this one's cosine and secant. So that's what the all students take calculus does, is it, in other words, you don't have to really worry about angles greater than 90 degrees yet. What we're going to do is take any angle they give you, and if it's in the second quadrant, I'm going to apply this to it to figure out what the equivalent first quadrant angle would be. Now, in the third quadrant, the formula is not 180 minus theta, it's theta minus 180. So if I said, what is the sine of 210 degrees, what's the equivalent first quadrant angle that we're talking about?
Would it be...
Plug the angle. Yeah, plug it in for theta. Yeah.
Would it be, I don't know.
Well, what's 210 minus 180? If you plug the 210 in for theta, then it's 210 minus 180. That's 30. Okay? Now, what's the sine of 30 again? Jacob, you still there, or did I lose you? Jacob, I think we have an audio problem. Your audio connection has been lost. Attempting to reconnect now. Okay. Connection lost. Please play. Okay, I'm going to call you on the phone, and we're going to have the rest of our audio by phone. For some reason, I don't hear you anymore. Hi, Leslie. We lost the audio through GoToMeeting, so I figured we could finish it on the phone. So.
Yeah, that's it.
Can you still see my screen, Jake? You didn't lose the video, did you?
No, I saw the
Okay, what number am I writing down here on the lower right?
No, I can't see that.
So you've lost the video also. You're not seeing it in real time. You didn't see that I just wrote an 8 there? In other words, I'm writing a number. You see where it says sine of 30?
Yeah, it's not perfect. No, it doesn't see it. Can we log in again, maybe?
Yeah, try that. Log out and log back in using the same meeting ID number that I sent you.
Okay, let's do that.
We may get our audio back, but at least we'll get the video. You got to be able to see what I'm writing. Now, to log out, you just hit the X on the go to meeting. Have you hit that?
Yeah.
Because it still shows you as being logged in. I'm wondering. I wonder if there's an internet problem here.
Yeah, I lost the meeting.
Yeah, I bet it's not going to let you log back in. Go ahead and try to log back in as soon as you get out.
You're doing that.
It might let you get back in. The fact that it lost the audio, that's the first time I've ever seen this happen, where it lost it for such a long time.
Yeah, I don't know what's happening.
Makes me think that it could be an internet problem on either of our ends. Can you go to another website? Can you open up a browser and see if you can get to a website?
I mean, I just rejoined your meeting.
Okay, go ahead and put the meeting ID number in there.
Yeah, he did.
Are you seeing my screen yet?
No, it says that.
Now it says Jake has arrived. It says my network connection has been reestablished. So can you see what number I'm writing below the sine of 30? I think we're going to have to hang the phone up because it's interference. Okay, can you hear me through the GoToMeeting now?
Yeah, I can.
Okay. Can you see the number I wrote below sine of 30?
Nope.
There's no numbers, David. It says meet now.
I wrote the number 7 right below on the lower left.
No,
Nope.
no, nothing in there. Okay, it doesn't show anything.
So I'm going to write a 2-digit number near the middle of the screen, below the A. Can you see what number I just wrote?
Back in here.
You can't see the number 12?
Hello?
And you can't hear me?
Hello? David?
Yeah, I
Stopped working again.
yeah. I'm going to call.
Yeah, it stopped working again, David.
Stopped or started?
It stopped.
Okay.
We have this screen here. Can you write something in there?
Yeah.
So we can see.
I'm going to write, I already did. I wrote a number below the letter A.
Are you back?
Back in there.
Now the audio is working again.
Oh, yeah. Now it's working. Uh-huh.
Can you see the number I wrote below the letter A?
12.
Yeah.
Okay, everything's copacetic. Let's hang up. We don't, I guess you did already. Okay, good. Okay, let's continue on. Let me erase some of this stuff. I'm going to leave on this page everything that I want you to memorize, okay? Now, let's go back to the sine of 210, okay? That is going to have the numerical result that is the same as the sine of 30. Well, what's the sine of 30?
Negative 150.
Look at my two triangles. What's the
It'd be 150.
what is it?
150.
What's the sine of 30? Look at this 30-60 triangle. What's the ratio of the opposite over the hypotenuse?
1/2.5.
Okay, that's what it is then. That's what the number is. Now, I'm in the third quadrant, right? Because the real angle is 210. So I need a plus or a minus sign in front of this 1/2. Third quadrant. What's positive in the third quadrant? Everything else is negative. So what is sine in the third quadrant?
I don't know.
All students take calculus. Tells you which trig functions are positive in these quadrants.
Well, tangent's positive.
Okay, so what's sine? If tangent's the only one that's positive, then sine has to be what? Hold on. Sine has to be negative.
Mm-hmm.
So the sine of 210 is going to be negative 1/2. So that's the way we're going to figure out the trig function of any angle that I give you. Is you're going to figure out what its first quadrant equivalent angle is. You're going to use these triangles to come up with that ratio. And then you're going to put a plus or minus sign on it determined by ASTC. So let's give you some practice. I'm going to give you a bunch of them, and at this point, you really should be able to do all of them. And all you needed to do is memorize what you see on the page. Now, there's one last thing. In the fourth quadrant, it's 360 minus theta. Okay? So tell me what the tangent of 225 is. First of all, identify the quadrant.
Yeah.
What?
Okay.
What quadrant is 225 in?
Third.
Okay, because that's 180, that's 90, and that's 270. Okay, so it's third quadrant. So which formula do I use to convert it to a equivalent first quadrant angle?
Subtract a 180 from it.
So what do you get?
45.
So it's the equivalent of a 45-degree angle. And we know what the tan of 45 is. What is it?
1/1.
And now, what's the plus or minus sign for tangent in the third quadrant?
Plus or minus sign. It's positive.
There you go. You just figured out the tangent of 225 all on your own. Now I'm going to give you a bunch to test you. What's the sine of 330 degrees? Which quadrant?
Fourth.
So what's its equivalent first quadrant angle?
That would be 30.
What's the sine of 30?
1/2.
And what is its plus or minus sign?
Minus.
There you go. 20 minutes of highly full of technical problems, and you can figure out any trig function of any angle as long as it is a multiple of 30, 45, or 60. Using what you see on the screen and nothing but what you see on the screen. Okay? So that's huge. That means no matter what I give you, you're going to be able to answer it. So let me give you another one. What's the cosine of 315?
That would be 45.
Okay. Cosine of 45 is
1 over square root of 2.
okay. Let's not worry about rationalizing that. Now put a plus or minus sign with it.
Plus.
You got it. I'm convinced you could do any angle now, except quadrangles. So let's talk about the quadrangles. You know what I mean by a quadrangle? Okay. Now, the easiest way to do the quadrangles is really to memorize the sine curve and the cosine curve. And you're going to have to do that at some point. But there's actually a slightly easier way to do it. Okay? Why did that happen? Remember when we're talking the unit circle, they want you to put the x and y coordinate on that end of that ray, right? Well, guess what? X is equal to the cosine of theta, y is equal to the sine of theta. So what coordinates belong there?
Cosine, sine theta, cosine theta, sine theta.
Well, no, cosine of 30 degrees. In other words, incorporate this 30-degree angle there. We're trying to figure out what's specific. So what's the x coordinate going to be?
Cosine of 30, and then...
Which, give me a number. Look and tell me what the cosine of 30 is.
Root of 3 over 2.
Okay, so that's what goes there. Now what's the sine of 30?
The sine is 1/2.
So when they say they want you to memorize the unit circle, what they really are saying is that you need to be able to figure out the sine and the cosine and the sine of all of these angles that are multiples of this, right? That's what they're saying. In other words, that's the cosine of 30, and this is the sine of 30. So the x and y coordinates are merely the cosine and sine of that particular angle. You with me? Now let's talk about the quadrangles. 0 degrees is a quadrangle. If I go to the end of that ray, what are the coordinates on that point for my unit circle?
0, 1.
Well, 1, 0, right? Now tell me what the cosine of 0 degrees is.
The cosine of 0 degrees would be 0.
No, look at this. Remember the x-coordinate is cosine of that angle. Let me erase the 30-degree angle so it's not getting in your way here. I'm talking about a 0-degree angle, which represents the heavy black line. And I know that since I'm talking about a unit circle, this coordinate is 1, 0. Well, the 1 is the cosine of theta. So therefore, the cosine of 0 degrees must be 1. What's the sine of 0 degrees?
Should that just be 1, 2?
No. The y-coordinate is the sine, the x-coordinate is the cosine. So the sine of 0 has to be 0. Now let's talk about 90-degree angles. If I draw my vertical line there representing a 90-degree angle, what are the coordinates of that point?
1, 1.
No, What are they?
1, 0, no, 0, 1.
0, 1. What is the cosine of 90 degrees equal to?
0.
What is the sine of 90 degrees equal to?
1.
Now let's go and look at a 180 degree angle. What are the coordinates of that point?
-1, 0.
So what's the cosine of 180 degrees equal to?
-1,
And sine of 180?
0.
Finally, we'll take the 270, the last one. Coordinates on the point at the end of the ray?
0, -1.
What's the cosine of 270?
0,
And the sine of 270?
-1.
There you have it. Now you can do all angles in the unit circle as long as they are multiples of 30, 45, 60, or 90 by using this method. And you didn't have to memorize any graphs. This method works really beautifully for your quadrangles. Quadrangles being multiples of 90. Right now, not one last thing, but now let's talk about angles greater than 360. So if I say, what's the sine of 390, what's the first thing you got to do?
Subtract.
Subtract as many multiples of 360 as you can. So that's the equivalent of the sine of 30. So that's 1/2. Okay? If I said, what's the sine of 750, subtract as many multiples of 360 as you can.
Still get 1/2.
In other words, that's the same as the sine of 30. So it's still 1/2. So now you are ready to give all 6 trig functions of any angle, whether it's inside the unit circle or not. One last thing is negative angles. What quadrant is that in?
4th.
So what is the equivalent angle that, if I wanted to write that as a positive angle, what would it be?
390.
Well, 330. In other words, if I draw it, now I'm going to have a hard time erasing this stuff without erasing my grid, but I'm going to try. Yeah. Just draw another line through there. Okay, here's my negative angle. Okay, positive angles are measured counterclockwise, negative angles are measured clockwise. So there's the angle. Well, that's the same as this angle, right? So what's the big positive angle? 330. You see why it's 330?
Mm-hmm.
Okay. Now we can use the same formula we've been using the whole time. The sine of 330 is the same as what first quadrant angle?
30.
Right. And we know that's 1/2. But it's in the 4th quadrant. So what is the plus or minus sign on it?
Minus.
You got it. Now, there's a couple of rules about negative angles that I could teach you, but this is one way to do it. This is actually not the fastest way to do it, but it's one way to do it, which is to convert your negative angle to a positive angle, just like I did, and then use the same rules you would normally use to figure out what the sine of 330 is. With me?
Mm-hmm.
Now, as long as we're talking about negative angles. Well, I want to erase some of this stuff because I want to leave everything that's on here, I want you to memorize. And
Yeah.
if you do, you will be able to answer all of these things. Let's see, I've got the all students take calculus. I got quadrants 1, 2, 3, 4. I got 180 minus theta in the second, theta minus 180 in the third, 360 minus theta in the fourth, and I got all four terminal points of the ray that would represent 0, 90, 180, and 270. In other words, those four x's that you see. And what that allows you to figure out is the quadrangle. So tell me again what the sine of 270 is?
90, so...
No, sine of 270.
What?
It's this point right here, right?
Yeah.
First coordinate is the cosine, the second coordinate is the sine.
So -1.
-1. Now, let's talk about odd and even. Actually, if you memorize everything you see, if I were you, I would take out your camera and take a picture of this right now.
Okay. Hold on one sec. Alright, here one sec.
This
Alright, I have a picture.
gives you all of the information you need to find any trig of any of the common angles. It won't let you find the sine of 29 degrees, but it'll let you find the sine of 30, 60, 90, 120, 150, 180, and so forth.
Mm-hmm.
For all 6 trig functions, using just the information you're looking at there. Now, remember last time we talked, I said the secret to memorizing 16 things is to memorize it in small groups. Well, SOHCAHTOA is 3 things, right?
Mm-hmm.
This triangle, this 30-60 triangle is 3 things. And that is the side opposite the 30 is 1, the side opposite the 60 is √3, and the hypotenuse is 2. You need to memorize those 3 numbers and where they go on that triangle.
Mm-hmm.
Same thing with the 45-45. I call them the unit special triangles because the side opposite the smallest angle is always 1. So there's really only 2 things to memorize, right? And there's only 1 thing to memorize over here.
Mm-hmm.
Okay. Also look at my unit circle grid. All students take calculus. That's 4 things to memorize. 180 minus theta, theta minus 180, and 360 minus theta. That's 3 things to memorize. And these 4 terminal points for the quadrangles, you don't even have to memorize those. You can figure out what those are just by knowing the XY coordinate system. And these 2 things over here, last but not least, know that the x-coordinate is always the cosine of theta and the y-coordinate is the sine of theta. So when you get to this giant circle and they want you to label all points, you can do it.
Mm-hmm.
In other words, this first point, that's going to be the cosine of 30 degrees, which is √3/2, comma the sine of 30 degrees, which is 1/2. So that would be the answer that you would label that point. So at this point in time, you can do every slice on the unit circle. You agree?
Mm-hmm.
There is no angle I could give you that would give you any problems. So let's go back and talk about negative angles again. First of all, you have odd functions and you have even functions from your algebra. An odd function is sine. And what an odd function says is that if I take the sine of a negative x, it's the same as negative sine of x. Whereas an even function, cosine is even. If I take the cosine of negative x, I get just the cosine of x. Okay? Now let's go back to that problem where we had the sine of negative 30 degrees. Remember how we did it? I converted it to the sine of 330, and then that converts to the sine of 30, and then that's equal to 1/2, but then I have to put a negative on it because it's in the fourth quadrant. Well, I can avoid one of those steps big time by using the fact that it's an odd function. The sine of minus 30 is the same as minus sine of 30. And now I do not have to bring in the 330-degree angle into the equation. I know what the sine of 30 is. That's 1/2. Stick the negative sign in front of it, and you got your answer. You with me?
Yep.
The other trig function is tangent, and it is also odd. In other words, the tangent of negative x, a negative angle, is equal to the negative tangent of the positive angle. So sine and tangent are odd, cosine is even. Let me test you. What's the cosine of minus 60?
The negative cosine of 60.
Well, look up the even functions. Cosine of minus angle is the same as cosine of the plus angle. So that's equal to the cosine of 60.
Mm-hmm.
Well, now look at that triangle. What's cosine of 60?
That would be √3/2.
No. Cosine is adjacent of 60.
1/2.
So 1/2, right? And there's my answer. I don't even have to figure out which quadrant it's in. In other words, I get it immediately by the odd and even property of these three trig functions. And obviously, if sine is odd, then cosecant is also odd. If tangent is odd, then cotangent is odd. And if cosine is even, then secant is even. You with me?
Mm-hmm.
So now you have an easy way, if you memorize these three things on the upper left here, now you have an easy way of handling negative angles. And it is by far the easier way than the first way I showed you. In other words, notice that to the right side of the equation, these are all positive angles. On the left side, they're all negative angles. So anytime you get a negative angle, merely use this identity to turn it into a positive angle. Sometimes you need a negative sign in front, sometimes you don't. Now, at this point, you are looking at the page that will allow you to answer every single angle, positive or negative, less than 360 or greater than 360, as long as it is a multiple of 30, 45, 60, or 90. That's pretty powerful. That's a lot. That's huge. You can't even begin trig unless you can do that. That's why I was frustrated the other night, is because I didn't get a chance to teach you this method. You started me off right in the middle of, basically you had to know your unit circle to be able to answer those questions, and you want to start trig at the beginning, not in the middle. This is the beginning. Okay? Now, one other thing. And that is, things are in radians. Let's talk about radians and degrees. Let's scroll down here. Tell me what this is in radians. I'll tell you.
Yeah.
And here I want you to notice
1/3.
Notice this.
30.
All these common angles we've been talking about, these two numbers multiply to 180. Those two numbers multiply to 180. Those two numbers multiply to 180. So converting these angles into radians is actually far easier than using that conversion formula they taught you. You can use it, but this is easier. What is the radians for 90 degrees?
Pi over 2.
Yeah, and basically what I'm going to do is take that and multiply it by 3. In other words, 30 is a third of 90. So 90 has to be 3 times that, and that's how you get pi over 2. So tell me what, excuse me, I got an extra 0 in this one right there. That's pi over 3. Okay? So tell me what 3 pi over 4 is using this easy method. If pi over 4 is 45 degrees, what's 3 pi over 4?
135.
That's the way to do it, is to memorize these, and you already memorized that 90 is pi over 2. Again, 90 times 2 is 180. Okay? So now that only applies if your numerator is just pi. Notice in all 4 of these on the left, I've got just a pi in the numerator. But when I'm presented with a numerator other than pi, like 3 pi over 4, I can tell that 3 pi over 4 is exactly 3 times pi over 4. Okay, and that's the easy way to do it. What is 2 pi over 3 equal to?
180. No, 120.
So using this system of converting between radians and degrees is a rather nice one. Now, the official way, if I'm going to convert 30 degrees, is to multiply it by pi over 180. That's the official conversion factor. It gives you pi over 6, same thing. Okay. Now let's go back to our unit circle. And the only thing that really needs to be put in radians are that 90 could also be labeled pi over 2. This 180 could be labeled pi. This 270 is excuse me, 3 pi over 2. And you see this in the second quadrant where it says 180 minus theta? In radians, that's pi minus theta, right? You with me?
Yep.
In the third quadrant, instead of theta minus 180, what is it going to be if I'm dealing in radians?
Theta minus pi.
And in the fourth quadrant, if I'm dealing in radians, what is it going to be?
2 pi minus theta.
So if I said to you, what is the tangent of 4 pi over 3? Which quadrant are we in?
Third.
So which equation do we use?
Tangent.
Well, we use theta minus pi as our conversion.
Yeah.
In other words, we're trying to take this third quadrant angle and figure out what is the equivalent first quadrant angle, which is what they call the reference angle in your class. It's just I've always found it easier to teach if I relate every angle to a first quadrant angle. And you do that by using these formulas. So plug in 4 pi over 3 in for theta. What do you get? What's the tangent of 4 pi over 3 minus pi? What's the angle? What's the equivalent first quadrant angle?
10 pi over 3.
Pi over 3, okay. And now go up, and what angle is that? What's pi over 3? Remember, the denominator has to multiply the angle to come up with 180. So what angle is that?
30.
30 times 3 is not 180.
No, wait. 45?
60.
No, 60.
Basically divide that number into 180. So that's the equivalent of a 60-degree angle. And now read your triangle. What's the tangent of 60 degrees?
Square root of 3.
Okay, and now put a plus or minus sign on this.
Plus.
Because we're in the third quadrant. There you go. Now you can do any angle, whether it's in degrees or radians. Whether it's positive or negative, whether it's greater than 360 or not. And it's all done by memorizing stuff in groups of 3 and 4, not in groups of 16. So let me erase this, because this is a problem. You don't need to memorize this. Everything else you see on that screen you want to memorize. Everything. Because you need every single piece of information on here to be able to do the unit circle or negative angles. Clearly, negative angles, if you use these top 3 things on the left here, you can turn it into positive angles really easily and quickly. But you got to memorize those 3 relationships. So did I fulfill my promise or not? I promised that you could do the unit circle on your own by the end of our session. And I believe you can do it now. And that's just the start. You've got to be able to do that before you can go beyond with Trig. You can't go to step 2 without knowing this. And the homework that you gave me the other night, that we only got through the first 4 problems?
Yeah.
The next 10 problems on that were trig functions of angles that are multiples of 30, 45, and 60. They may be in degrees, they may be in radians, but they're all multiples of 30, 45, 60, or 90. The only thing you might not be able to do, there's one other thing here that's worth knowing, and that is the tangent of theta is always equal to the sine of theta divided by the cosine of theta. So what's the tangent of what's the tangent of 90 degrees?
The tangent of 90 degrees would be...
Excuse me, I meant the tangent of 0.
Tangent of 0 would be -1.
No, it's the sine over cosine. Here's where you find the sine and the cosine, right there. What's the cosine?
Cosine 0.
Of 0 is what? Remember, we take trig functions of angles to get numbers. This first coordinate is the cosine over here. X is the cosine. Y is the sine. So what is the tangent of 0? What's the sine of 0?
-1.
No, sine of 0 is the y coordinate on this ray right here that I circled.
Oh, 1.
0. The sine is the y coordinate. Cosine is the x coordinate. So sine divided by cosine is 0 divided by 1. The tangent of 0 is 0. However, here's where it gets tricky. What's the tangent of 90 degrees?
Undefined.
You got it. Very good. Because it's 1 divided by 0. In other words, 90 degrees, the sine is 1, cosine is 0, and I can't divide by 0. When I divide by 0, I get undefined. So there's a lot of trig functions that are going to have undefined. You're going to be dividing by 0. Notice that since your other 3 trig functions are reciprocals of the main 3, whenever any of the main 3 are equal to 0, well, the reciprocal is going to be undefined because that means you're going to be dividing by 0. So this you want to memorize also, because I really only taught you to figure out the sine and cosine of the quadrangles. But using this identity, you can know the tangent of all 4 quadrangles also. Just make sure it's sine over cosine, and make sure you know that the x-coordinate is the cosine and the y-coordinate is the sine, based on what I've written over here on the lower right. All right. I think you're good to go, but you got to memorize this stuff. And by memorizing it, I mean being able to create it from your brain. In other words, if I presented you with a blank sheet of paper, could you draw these 2 triangles?
Yeah.
Can you dimension them?
Yeah.
Okay. And you can draw the unit circle, and you know all of these sub stuff that you have to memorize? I think you're good to go. You're good to go to the next section of trig. And you would get every single problem right on that last homework sheet you gave me. This is the way trig should be taught, not the way they teach it in your class, I'm sorry to say. I don't say that very often, but with trig, I do. This is the only way to learn trig, so that you can do that very, very first thing they expect, which is to be able to draw the unit circle and label it. All 16 slots. But you do have to memorize everything you see on this page. Everything. All right, Jacob, I am going to let you go. Let me just check my calendar here to make sure I got your next session scheduled right. Wow. You know what? It almost looks like my internet went down for a few minutes. My calendar didn't work either until just now. I'll bet you all the problems we had was because of my internet, not yours. So let's see. I got you tomorrow at 4 for a half an hour?
Yeah.
See you then. Bring some homework. We'll get back to your homework.
All right.
Okay. Talk to you then. Bye-bye.
All right. Bye.